We now discuss the solution of a problem from the section Integral Calculus. The problem is on the areas of the bounded regions. This problem has appeared in the joint entrance examination main held on 24th June 2022 in the first session. The problem is, let S be the region bounded by the curves y is equal to x cube and y square is equal to x. The curve y is equal to 2 times mod x divides S into two regions R1 and R2. If the maximum of R1, R2 is equal to R2, then R2 by R1 is equal to. So we are given a region named as S bounded by these two curves y is equal to x cube and y square is equal to x. And a curve y is equal to 2 times mod x is given to be dividing S into two regions R1 and R2, and the maximum of these R1 and R2 is R2, then R2 by R1 is equal to. We now discuss the solution of the problem in detail. We are given these two curves, and these two curves are very familiar, and y square is equal to x is a parabola with vertex at the origin and opening towards the right, and y is equal to x cube is a very well known curve. Now, where do they intersect? These two curves, where do they intersect? To know that, y square is equal to x and y is equal to x cube means y square is equal to x to the power of 6. X is equal to x to the power of 6 will imply x times x to the power of 5 minus 1 is equal to 0. X is equal to 0 or x to the power of 5 minus 1 is equal to 0 implies x is equal to 1. So x is equal to 0, 1. And when x is equal to 0, y is 0, that is the origin, 0, 0. When x is equal to 1, y is equal to 1. So it is 1, 1. So let's look at the diagram. So this is the blue curve, that is y square is equal to x, the parabola, and the red one, y is equal to x cube. They intersect. So the coordinates of the points of intersection are the origin O 0, 0 and A with coordinates 1, 1. Now given S is the region bounded by the curves y is equal to x cube and y square is equal to x. So this is the region S. So this is the region S. So what is the area of the region S? So to know the region, to know the area of the region S, so we have drawn a line x is equal to 1. So this is integral 0 to 1, so 0 to 1 for upper limit, that is y is equal to root x minus the lower limits y is equal to x cube. So integral 0 to 1 root x minus x cube in brackets with respect to x. Integrate. If you integrate, the first one will be x to the power of 3 by 2 by 3 by 2 minus x to the power of 4 by 4 to be evaluated between the limits 0 to 1. Now 1 by 3 by 2 is 2 by 3 into x to the power of 3 by 2 from the upper limit to the lower limit, it is 1 minus 0 minus 1 by 4 x power 4 from x is equal to 1 to x is equal to 0 is 1 minus 0, and this is 2 by 3 minus 1 by 4, and when simplified it is 5 by 12. So the area of S is 5 by 12. Agreed. Now, given the curve y is equal to 2 times mod x divides S into two regions R1 and R2. So now y is equal to 2x divides S into two regions, since the region S is entirely in the first quadrant. So it's like this. The V shaped is y is equal to 2 times mod x, and y is equal to 2x is the curve that is in the first quadrant. So now this line y is equal to 2x, is it going to intersect y is equal to x cube or y square is equal to x? That's the question. Now suppose you take the straight line connecting 0, origin and a, and that will be y is equal to x. So that is the y is equal to x, which divides S into equal parts. But now y is equal to 2x. Notice that the slope is more than the slope of y is equal to x. So when the slope is more, it will bend towards the y-axis. Therefore, it intersects y square is equal to x, not the y is equal to x cube. So what is the point of intersection? So the point of intersection we will find as x is equal to y square, but y is equal to 2x, that is y square is equal to 4x square, and that will imply x into 1 minus 4x is equal to 0. That will give you x is equal to 0, and 1 minus 4x is equal to 0 will imply x is equal to 1 by 4. So this will give you x is equal to 0 and x is equal to 1 by 4. When x is equal to 0, y is equal to 0. When x is 1 by 4, y is equal to 2x, 2 into 1 by 4, that is 1 by 2. So what is the point of intersection? The origin 0, 0 and 1 by 4, 1 by 2. So the coordinates of the points of intersection are the origin and B. This is B. This is the coordinates are 1 by 4 to 1 by 2. So now the area of R1, the area of the region bounded by y square is equal to x and y is equal to 2x. So this y square is equal to x and y is equal to 2x. This narrow region, this is that is R1. So that is R1. So now drop a perpendicular, x is equal to 1 by 4. So the area will be integral 0 to 1 by 4 upper limit root x minus lower limit 2x, lower curve, upper curve y is equal to root x minus the lower curve y is equal to 2x. Yes, integrate x to the power of 3 by 2 by 3 by 2 minus integral 2x is x square to be evaluated between 0 to 1 by 4. Now this is 1 by 3 by 2 is 2 by 3, and for the x to the power of 3 by 2 for the upper limit is 1 by 4 to the power of 3 by 2. For the lower it is 0. Minus x square, that is 1 by 4 whole square. For the lower it is 0. Now 2/3 into this is 1 by 8 minus 1 by 16. Yes, that is 1 by 48. So this the area of R1 is 1 by 48. It's very obvious now. The remaining part is R2. Therefore, the area of R2 will be area of S minus area of R1. We will see in the next slide. Yes, that's what we have. Now, area of R2 is equal to the area of the region S minus the area of the region R1, and that is 5 by 12 minus 1 by 48. And that is 20 by 48 minus 1 by 48, that is 19 by 48. And the area of R1 is 1 by 48, the area of R2 is 19 by 48. The maximum of these two is the area of R2. Now we have to find the area of R2 by the area of R1 is equal to the area of R2 is 19 by 48 by the area of R1 is 1 by 48. 48 cancels, and you will get 19. That's your answer. So R2 by R1 is 19. That's our answer. That is the discussion of the solution of the problem based on the areas of regions from integral calculus. I I am sure that you have understood the solution of this problem, and almost every time we are getting a problem on areas bounded by the curves. Please concentrate on them, and I wish you all the best. Thank you.